All right, Chapter 1 test, version 2, number 3. So we're given this triangle, JKL, and I'm going to make these letters bigger because I can't deal with the little guys. So J is 4, 5. I also like to label the coordinates on there. K is 6, 1, and L is negative 5, negative 2. Okay, now I can see that easily. Okay, first thing, slope of JL. Well, a lot of you guys on the test tried to use the slope formula, which is totally fine with me as long as you remember what the slope formula is. But a lot of you actually messed it up, put pluses here, or put the x's on top instead of the y's. If you have this down, I got no problem with that. But in class, you're going to see me do a more geometry interpretive way of doing this, which is to draw in the slope triangle. So JL is this guy right here. And so I'm going to sketch a slope triangle using just horizontal and just vertical lines. So straight up here and straight across here. Now if you're having trouble figuring out how to draw these triangles, definitely come talk to me. Okay, this is something you're going to have down, not just for a slope, but for a lot of different things in this class. So if I go straight up, right, how long is this thing? Well, that's negative 2 to 5, because only the y's change when you go up and down. So big minus little, 5 minus negative 2 gives me 7. So this length right here is 7. Okay. This one right on top here, well, I'm going, now the x's change. So I'm at negative 5, and I'm going up to 4. So big minus little, that's 9. So this length right here is 9. I'll make that a little bit better, 9. Okay, now remember, the phrase for slope is rise over run. Well, the rise is 7, the run is 9. And then don't forget to check, is it going uphill or downhill, right? Well, it's uphill. And in case you forget how to read the graph, you're reading from left to right. That's why it's going uphill and not downhill, the opposite direction. Or remember, think of it as a graph of your money. And is that good or bad? Well, money going up, good. So nobody ever seems to mess that up. It's a positive slope. 7 over 9. Okay, now we need the midpoint of KL. So let's take a look at that. Here's KL. Midpoint, I don't know, I'm going to guess it's roughly there. Just to have an image of it. And that way we can check when we're done. Does that look like the midpoint of KL? Well, remember, the midpoint's stuck in the middle. So we want the middle value of our x's, and we want the middle value of our y's. So another way of getting the middles are to average them. So we're going to average the x's, and then we're going to average the y's. And remember, if we have two numbers, then the average is just going to be add them and divide by 2. So the average of the x's is negative 5 plus 6 cut in half. And then the average of the y's, negative 2 plus 1 cut in half. So that's going to come out to be negative 5 plus 6 is 1 over 2 there. And then the other one's going to be negative 1 over 2. So it's 0.5 and negative 0.5. Or you could leave them in fraction form if you prefer that. And if you look at the picture, it sure looks like that's about halfway over on the x-axis and halfway down along the y. So, okay, so it looks good. Now the question is, do we have a scalene, isosceles, or equilateral triangle? And remember, they even give you the definitions here. Scalene, no sides are equal. Isosceles, 2 sides are equal. Equilateral, 3 sides are equal. Okay, well that means we better figure out stuff about the sides, right? So you can use the distance formula, but a lot of people who tried to memorize this thing got it wrong on the test. And that's a problem, because it's not an easy to remember formula. Where's the plus go? Where do the minuses go? Why are the squares there? Got to remember to take the square root at the end. Well, that's the reason that I like drawing these slope triangles in, because you can use these, but not for slope. You use them to figure out this length, because if you think about it, well, here's a big right triangle, right? And we know one side's 7, one side's 9, so we can use Pythag to get the missing side. So let's do that. 7 squared plus 9 squared equals JL squared. Okay, well, 7 squared is 49. 9 squared is 81. And if we add those together, we get 130 equals JL squared, which means root 130 equals JL. And remember, for now, I don't care if you try to simplify that or not. So this side right here, root 130. Okay, let's figure out another side. Let's try blue. So if I want to figure out this side here, right? Well, I'm going to make my slope triangle. So I'm going to go over, and I'm going to go up. Only horizontal and vertical lines. Okay, so when I go across, only the x's change, right? So I'm going from -5 to +6. Big minus little. 6 minus -5. 6 is the same as 6 plus 5, so that's 11 units. Right here, I'm going up and down, and so only my y values change. So I'm going from -2 to 1. So big minus little, 1 minus -2 is 3. Okay, now I can do the Pythag step. So I'll do that down here. 3 squared plus 11 squared equals KL squared. 3 squared is 9, 11 squared is 121, equals KL squared. That's 130. And then you take the square root. Okay, well, now I know at least two sides are the same. So it's at least isosceles. Some people stop there. That's not technically enough. I know that the third side doesn't look the same, but you got to back it up with calculations. So you got to check the third side too. So let's do that one. I don't know. Oh. Sure, let's go lavender. Let's see what that looks like. All right, so here's my slope triangle. Right there. Okay, when I go across, I gotta use a different color. When I go across, x has changed, 4 to 6, so that's 2 units. And when I go up and down, y has changed, 5 to 1, 4 units. So here's my triangle. I'm gonna do Pythag on that guy. 2 squared plus 4 squared equals jk squared. Okay, well that's 4 plus 16 equals jk squared. That's 20. And then I take the square root. Alright, so now I got all three sides. This one's root 20. The blue one that we did earlier was root 130. And the red one already is done as root 130. So if you look at these things, well, two sides are the same, and one side's different. So since two sides have the same length, and the third side is different, then triangle JKL is isosceles. All right. If you needed to watch that one more time, go ahead and do it.